Hey everyone, we now have our VESC vehicle ready to be set up, and in this video we'll show you how we configure the VESC firmware for the first time. We do the motor detection, Imu calibration, and the basic setup. I have to warn you, this video is extremely long and boring. 30 minutes of nerd talk. I would only recommend watching it if you're actually converting your board to a VESC yourself for the first time, or if you have trouble sleeping or something. So, the cliff notes. We do run the motor wizard and set it all up, and it all works out of the box, but the motor feels a bit choppy. So then we run the motor wizard again, and it magically fixes itself. And that is it. So the video ends with us riding around in the garage. After that, we're ready for loading the real firmware, like my optimized firmware. So if you still want to watch it, go ahead. All right, so now let's turn this thing on and connect the VESC tool. And I also realized I forgot to put in a little beeper, but that's something we'll add the next time we open it. All right, let's see. We see the Little FOCer built-in Bluetooth. We connect to it, already connected. Let's check the firmware version. Let's see what's on there. It should be 5.3
Yep.
Stable, good. And now I would go straight to the motor wizard.
Where's that again?
Yeah, just under your mouse tip.
Right there? Yeah. Default parameters, yeah?
No. Now we choose EUC. Click next.
Oh, they had propeller this. I don't think that.
Now large outrunner, this one. Override. Advanced. So we leave that alone. Open loop 700 sensor list put to 3000 and motor poles to 30.
Where?
Below
Here?
that, yeah. Okay, next. Yes. Now, battery cells in series. Oof. This is a different type of battery. Let's see what the options are. Battery type.
Battery turn.
Click on that, yeah. I think that's what it is, yeah. It's
This
that
one?
life, yeah. To do that one. And say 16 in series.
But I thought it was a 14S.
Yeah, it's equivalent to 14S lithium ion, but it's 16S of those older cells.
Oh, okay.
And battery capacity, I don't know, it's like 2500 amp hours, I think. Oh no, it's amp hours. We want 2.5 amp hours. There we go. All right, now advanced. No, leave it alone. Next.
All right. They changed this from last time.
They did. This is 5.3. Okay.
Motor poles. We already set that at 30, right? Oh,
Wheel
what's-
diameter. Actually, the wheel diameter on the XR is a little bigger.
Yeah, it is.
Let's set it to 285.
Let's see on here. Can't.
Or actually, set it to 290.
290? Oh yeah, what is the actual?
Yeah, we'll have to. I'll measure it later.
Alright.
Okay. And motor poles 30. This looks good. Oh, direct drive is an important checkbox. All right.
Wait, what? There we go.
All right. And now run detection. All right. Let's cross our fingers that it all works.
Over canvas, right?
Nope.
Oh, okay.
We only have one VESC, so. All right. Let's go.
Alright. Hit okay.
Fingers crossed.
Oh, it's turning.
Sounded normal. Nice and smooth. And now that's the Hall sensors, I think.
Oh, the Hall sensors seem so nice on this.
Well,
because these are like, because we didn't screw them up.
All right, it did it all.
All right.
Let's see what the values are. 65. Oh, no, that's so 61 milliohms, 188 microhenry. Flux linkage 27. That all looks reasonable. Now go to motor settings, general.
All right, right there.
And here, cutoff start. Oh, I don't know what that should be. Just set it to 40. I want it out of the way. And the other one to 35. All right. And then next would be go to general first. That looks good. Current, next tab. Set it to 100 and minus 100. Hit Control A and to type in 100.
Okay.
Absolute max. Okay, because we have 100 amps on the max, we need 50% more for absolute max, so 150.
Okay, slow ABS current limit.
Sure, that can stay true. And then that is good, good, good. Battery current, let's set it to 30 and minus 30.
Oops.
All right, that one we can ignore. We don't have a driver chip.
Yeah, we do.
No, not in.
Yeah, we burned the last one.
Well, I know, but not in it. The Little FOCer V3 does not have a DRV chip in it.
Oh, okay.
Okay,
Voltage?
we did voltage already.
RPM.
Now we can do temperature.
Okay. Temperature.
We want that at 0. That's good. MOSFET. Oh, we can up that a lot. We don't have
to 80.
PLA. Yep, we can do 80 and then end to 90. 95 is good too. Leave it alone.
Okay.
And motor could stay as it is. And then BMS. We want to go to next tab.
We don't have one.
Exactly. So we want to say that. None.
Okay.
Advanced. So even if you do have a BMS, unless you have one connected over CAN bus, you want to say no on that one. Advanced. This all is fine. We might have to adjust the motor beta value later, but it could be 3900, but let's leave that alone. All right, now we need to go into FOC. So let's start with general.
Oh, yeah, I love this part.
That is good. Yeah, but we've already done that with the wizard, so we don't need to run it anymore.
No, but none of the values are in.
No, that's the values that matter are at the top. The values at the bottom in red are the ones that you would get from detection. So if you run those buttons...
Should we do it anyways, just to see if it matches?
Sure. Why not? Let's do it. Let's see if it matches up. Let's do it for science.
All right. Okay.
All right, so that's the first one. Then you do the flux.
This one.
Yeah.
Facing away. All right. Okay.
All right. So now let's compare the numbers. We're not going to apply them, but so we have 62 milliohms at the top in motor resistance, and at the bottom it gives us, holy moly, it gives us 592. That is a lot. So that's a huge discrepancy, and that's one reason why I prefer using the motor wizard over this approach. So let's look at the other numbers. Inductance is close, 197 versus 188. And then the LD, LQ looks pretty close, 47 versus 54.
That's, yeah.
And then the lambda value that's far off, 27 versus 40. Big discrepancy, observer gain, and so on. Okay, that's fine. Let's just ignore it. So that's why we ran the wizard. I think the wizard is better. Now, we will need to come back to here. Let's go to Hall sensors first. We'll set that to 2000.
Extra sample.
The first value we'll set from 3 to 2000. Because we want our transition to happen earlier. And then the next value, the interpolation ERPM, we want to have at 250, or let's say, no, let's put it at 250. 250, and that is good. Go to general again. And in here, we'll cut the observer gain in half, so 0.7, the very bottom, the last value.
All right, so 0.7.
No, go to general.
Oh, I thought.
The last value is 0.7. So that's some magic wisdom there that is supposed to cut it in half, and then you can lower your you can lower your transition ERPM for the Hall sensors. Okay. Let's write that.
That's this one, right?
Yep. Write motor configuration. Okay. Now.
Oh, encoder. That's like if you don't have any sensors anywhere, measure the position.
Yeah,
right?
There's no encoder on here, so we don't
That's
have
the
that
Hall
hardware.
sensors.
HFI, VSS, filters. Look at filters. Enable phase filters. We'll just leave it enabled. I've never really.
We're not doing field weakening.
No field weakening here. Offsets. So click on offsets. We'll leave it. It says run calibration at boot. That costs an extra 3 seconds during boot. We'll leave that on for now. And then after the next boot, it'll get saved, and then we don't have to run it again. So we'll turn it off, and then it'll start up quicker. Advanced, I don't think there's anything in advanced that we need to change.
That's a lot of stuff. All right.
Yeah, let's leave that alone.
Ready?
All right, so we got everything written. Go back to Hall sensors and check that everything got written correctly. Perfect. Can you read the values back? Oh, that's good. Oh yeah, now it read it. Okay. Looks good. All right, next we can go and enable the balance app.
Not PID?
Nope. No, we're done. We don't use PID controllers. We go to app settings, general.
Wait, where's the thing where you can control it with the keys? Is it real-time data, I think?
Oh, you want to control it with the keys?
Yep, that's it.
Yeah, yeah. I think you can control it even if you don't go into that tab.
Oh.
I think it's enabled by default if you have the UART app. But okay.
All right. So
that's fine. Let's go to general and enable the. Wait, I'm gonna make sure that it's turned off. Yeah, just enable it. Go enable the balance app, but it might start spinning like crazy.
Balance.
Oh no, it won't. Don't write it. Okay. So some people have made the mistake of switching to the balance app, writing it, and then the ADCs were set to 0, and the wheel would start spinning right away because the board is balanced, and it then considers the foot sensors to be pressed. So as long as we don't write, we don't have anything to worry about. So let's now go. So the app, we don't need to change anything in here, and let's go to the balance app now.
Balance.
App
Here.
settings balance. Okay, so go to the tune tab. The first one.
All right.
All right. So normally I would just load my XML file with this, but because this is 5.3 stable, we will just configure the basics, and because we don't have my features in here. So all we will do is put in PID of 3 and then 0.002.
Go on that. 0.002.
Is this the motor?
Yeah. Because I'm pressing the keys to... Here,
Oh,
I'll turn the keys
oh,
on.
wait.
I turned the keys on.
Oh, you had the keys enabled, yeah.
Alright, so 0.002.
Okay. 0.002.
That's not reading me right.
You need to delete the 0 and then you can add another number. There. Okay, it doesn't allow more than the 3 digits. Okay. And then D, let's do 500.
500?
Yeah.
That's a lot.
Okay. Now, the loop hertz is 1000. Then we need a low pass filter. That's critical. 10 hertz needs to be in there. If you don't have that, your motor will do some scary vibrations. Everything else we can leave alone, but let's set up our switches and everything. Oh, no, let's go to startup. The next, no, we'll stay here in the balance app. Now we want to go to startup. Okay. Yeah, those defaults are fine for now. Brake current, you can set that to 5 amps.
Oh yeah, brake current's nice.
We live in a hilly area, so we don't want the board to just shoot off. Now we can go...
Wait, brake timeout, what does that mean?
That basically means after 10 seconds it'll stop applying brake current. Unless the board is rolling, then it keeps going.
Oh, okay.
But that way it stops wasting energy when you're just having it parked somewhere. Now, tilt back.
Tilt back.
High voltage. So this battery goes to what, 58, let's just say 60 for high voltage, 45. Okay. Good enough. Faults. Let's go to the next tab. Okay, so pitch axis fault cutoff. Yeah, those are fine for now. We're going to load my XML file later anyway when we upgrade the firmware, but these are good. Then duty cycle, put that to 1. We don't want a duty cycle fault ever. 1.0, yeah, I guess that works. Duty fault delay, it doesn't matter now. Okay, here's the ADC switches.
Well,
so
we have to see what we get first.
RT app. Click on the RT app button here.
So get this data.
Yeah, so now what do we, where is it? Where am I looking? Okay. Oh, they're at 0 right now. That's suspicious. All right, they're not working. Great. We're going to have to take that apart. Shoot. That sucks. All right. But set it to 3 anyway, just in case they might, I don't know if they engage before we write, because we haven't actually written back that we've switched to the balance app, so maybe it's being ignored.
Yeah.
So let's just pretend like it's working. 3. Next one would be the delays. We want a half switch delay short, let's say 50. And then we want the full switch delay to be long, let's say 1000, that's 1 second. And then the half state ERPM needs to be low at about 200.
All right.
Maybe 250, but 200 is good.
You want 250?
200 is good.
Okay.
And multi-ESC we can ignore. Okay, so this is it. Now check the IMU. We want to make sure, go to the IMU app there. And here we need to change the sample rate to 1000.
sample rate 1000.
Yeah, the default is obsolete. It should be 1000.
We haven't written yet.
Yeah, do it right now.
This?
Oh, that's reading.
This.
Yeah. Ooh. Okay. Oh, you know what that could be? That could be the brake current. Set the brake current to 0 and see what happens.
Is that over here?
That was in
Tilt back.
startup, I think. Startup. Brake current, set it to 0 and write that. That is a weird one. Did the right happen?
Yep, that was it.
That was it. Wow, that's
they're working.
Yeah, the sensors.
So ADC1 and ADC2, they're both working.
Oh,
So
they're working really well. So
3.29
3.29
and 3.3.
Damn, they go all the way back down to 0 really quickly.
That's good.
That's really good.
Do they have built-in pull-down resistors? They might.
Maybe. Yeah.
So right now, that would be on.
And this is really good. Okay, great. So that means we don't have to open it. Good news. All right, great. Well, now the only thing that's left is Imu calibration. So go to Imu.
Okay. Imu. It's not tilted at all, but it thinks it is.
Yeah, don't go by that box.
Okay.
So, where is the Imu thing? Oh, here. You see detect calibration down there? There we go. All right. Now, hit play right here. Sorry guys, iPhone battery died here. Essentially, we'll do the calibration, we need to write the settings, and then we'll go and try it on the floor. So now, we just want to find out if it's going in the right direction. So we'll do the hand test. Got to hold on to it really tight. Some people have put holes into their walls doing this test. So you just hold tight, press on it, and let's see. Okay.
Looks like it's going in the right direction.
It's going in the right direction. Seems a bit choppy, but it's
Looks like
it's doing well. All right, time for our test dummy. All right, our test dummy is not wearing a helmet because he's a professional and because we have rings hanging off the ceiling. So he's holding on to those. And let's try it out.
Whoa, it started when I was like this. It started like this.
Oh, I think it was at 20 degrees.
It feels a little choppy, but
it works.
it's so choppy. It works.
All right. So.
Oh, foot pads work really nice.
All right, let me give this a try. All right, definitely balances, but it is very choppy. It's like as if I was going over a wooden bridge or something.
They're like a bunch of bricks.
Huh, interesting. Oh well. I think we should check our motor detection and see if those values come up different if we run we should run the wizard again and see what kind of values we get the second time around.
Alright.
But it works. Now we just gotta tune it and load the other firmware. Yesterday, my phone battery ran out when we did the Imu calibration, so let's repeat that. And also the motor settings, something isn't right. The motor was choppy. I think we need to rerun the wizard and see if we get better numbers and make that go away. So The board is on. Let's connect to it. Alright. The motor wizard here. Do not load the default parameters unless you really think that you screwed something. If you start modifying random values and nothing's working anymore, sure, try to load default parameters, but I definitely know that all my changes were good, so I don't want to load the default parameters. Ideally, I would only want it to do the motor detection stuff, but it does more than that. We selected EUC and large outrunner, 3030. Good. It remembers everything from the last time except for the number of battery cells in series. And just out of curiosity, I'm going to try something here and set my battery to, let's see here. I assume the way this is worded, I'm supposed to enter positive numbers for regen. So let's just see what happens. And it's still direct drive, wheel diameter is good, 30 poles. All right, let's go. And it's running. Some metal shards on the ground here. Alright, let's see what we get. Alright, I'm really liking those numbers now. I have to admit I screwed up the filming of this, so I've already run this now 3 times. And for 3 times in a row, I got a motor R value, the resistance, of just around 88, whereas yesterday we got 61. And 61 definitely was not very good. The L value was slightly lower, 190 something, but I think this all looks good. I'm just going to take that now. Not that I have a choice. Once you're at this step, it already did it all for you. And now, unfortunately, I have to re-enter my manual overrides here. I want 100 amps for max, minus 100 for regen and brake, and well, that didn't help, so maybe I should have entered minus 30 in the wizard. I don't know. Now voltage, I wanted 40 and 35, and everything else it didn't touch this time around. Now Hall sensors, we want 2000. We could try running the wizard with 2000 from the get-go, but I just don't feel comfortable doing it. So I just do 3000 and then change it afterwards. Because anyway, you have to cut the observer gain in half by hand. So I like to do both at once. And that is it. We write the motor changes that we made. Now we still need to do the Imu calibration, but basically what you want to do is you want to make sure that you change it from 200 to 1000 up here in the sampling rate. You want to select Mahoney from the drop down here, and that is all. And I'm lucky enough that the way the Little FOCer sits in the enclosure, that the yaw offset is 0. For some people it's 90 or minus 90 or 180. So now we just got to hit play here, start detection, and it will go. Doesn't take very long. Alright, and Now it is very important that you hit both apply and afterwards you hit the right app configuration. If you forget either one, or if you do it in the wrong order, then your calibration values will not end up in your VESC and you won't get the behavior you expect. So that is it. We still have the balance configuration from yesterday, so we are good to go. Let's just make sure that if I touch this here, that it starts turning. All right. And also one other thing, I know that for riding, I prefer to have my fault delays, especially the full switch delay. I like to have it at a full second, so if something's wrong with the sensor, if my foot comes off the pad for a very short amount of time, I don't want the board to shut down. So I like setting it to a second, so 1000 milliseconds. But in the garage, for your first tests, if the board shoots off and you jump off, you don't want the board to accelerate and hit your wall or garage door, so actually setting it to 50 for your first tests, you could even set it to 0, but something fairly unforgiving so that if you jump off your board that it doesn't keep going and hit furniture or whatever you got around. So, time to get on this board. Alright, I'm pointing the board away from the camera tripod so it doesn't knock out the camera if it goes. I'm holding on to my rings, and lo and behold, the bumpiness is gone. So it was indeed the motor detection values, and it is smooth as butter right now. Sweet! So I would say this was a success. Actually, out of all of my OneWheels, this was the least problematic build. Everything worked sort of out of the box, and we didn't break anything. The board already behaves really smooth. So, what? Yeah, we should be good to go. So the next step is I want to load my firmware on here and take this thing outside. All right. Thanks, guys. See you soon.